Section 3.2, day 1. This is going to be a mixture of things that you've learned and kind of just a review, to be honest with you. It's just going to be presented to you in a little bit of a different way. So, without further ado, there are cubics, and we need a little review on this. And if A is positive, it would look like this. If A is negative, it would look like this. And then we have our good friend the quartics, and I was a little politically incorrect, but it is a memory tool. A is greater than 0, that means you're a positive person, which means you're a winner. And then if you're negative all the time in a quartic world, I said moron. I don't mean it, it's just a good memory tool. Anyways, with that in mind, this is saying determine the x values that cause the polynomial function to be a 0. So let's just sit there for a second. It's saying find the zeros. Well, that's pretty darn easy because you've done a lot of these, and this one's already all factored out for you. So what would cause that to be 0? Negative 4. What would cause this to be 0? Remember the trick. Take the opposite of that, negative 1, divide by that, 2. What about this one? 7. So there's our zeros. Now what am I going to do with that? Well, here's the trick. Remember what zeros are. They are your x-intercepts. So what we're going to do is we're going to turn this into my x-axis without even drawing in my y-axis. It's there, but you're going to imagine that it's there. So we're going to put these in chronological order. So the negative 1/2, we're going to put it, well, actually the negative 4, and then the negative 1/2, and then the 7 would be way over here somewhere. And now we have to ask ourselves these questions. Where is the graph positive? Where is it negative? So to be honest with you, for steps B and C, we have to know our rules from up here and possibly over here. Depends on if it's a cubic or a quartic. So if I just concentrate on this times this times this, wouldn't I get 2x cubed? Which is telling me two things. Number one, it's a cubic. Number 2, a is greater than 0. That's my a, okay? Which tells me it's going to look like this. Also, remember what we learned in the past. If these are odd multiplicity, it's going to go through the x-axis. So I just kind of duplicate this drawing because a is positive. I know it's going to go up to the right. I know it's going to go down from the left. And then because it has to go through here and here, it's going to go like this. Now, I don't know how high it goes or how low it goes, but in this case, it doesn't matter. So the question for B is, where is it positive? Well, that's anywhere above the graph. So where is it positive? That would be between negative 4 and negative 1/2. And then that would be from 7 all the way to infinity. Now, where would it be negative? Well, that's anywhere it'd be below the graph, so that would be here. How do I say that? I say from negative infinity all the way up to 4, and then I look in between this space, that would be negative 1/2 all the way up to 7. All right, so moving on to the next sample problem, same sort of deal, but there's a little difference here. That right there, that even multiplicity means that this 0, it's going to bounce off. So you have to be careful with that one. This one tells us that 0 will go through the x-axis. This is a 1, so it's going to go through the x-axis. So let's just find our zeros. Okay, so negative 3 would be one of them, 2 would be one of them, and 5 would be one of them. So we're going to start with our furthest left. We're going to say, all right, there's one of them. There's another one, and there's another one. Now we got to do our thinking. So x squared, okay, times x would be positive x to the 4th. There is an invisible 1 there. So we know it's a quartic, and we know a is greater than 0, so we know it's a winner. Problem is, it's going to bounce off negative, or it's going to bounce off 5. So if I start with the outer part of the drawing, I go here, I know it's going to go like that. I go here, I know it's going to go like that. Again, accuracy, no, not worried about that at all. Just general truth. So I know it has to look like this, but it has to bounce off here. So it's got to go here and then up. And because this is odd multiplicity, it's going to go through the 2. And it's also going to go through the -3, and it just kind of works out. So letter B is asking us to figure out where is it positive? Well, it's everything above the x-axis. So that would be -infinity all the way up to -3. And then from 2 to 5. And it does have a break in it because it does, that's our 0. And then it's also from 5 to infinity. Okay, so this is an above the graph section, and above the graph section, and it seems like all of this is one, but it's not. That's a section, that's a section. That's why we have 3 different pieces to our answer. And then this is the only piece that's below the x-axis, meaning negative, so it's -3 all the way to 2. And there you have it. This one is going to force you to do a little work before you get to analyze it. That's all. So we look at this one and we say, aha, I think we can factor that. So 2x minus 7, so you can't do anything with that. But I can factor this one right here. So it says x minus 2, x minus 2 greater than 0. Now here's something you have to understand. What does greater than 0 mean? You can say is positive. What does that mean? It means it's above the x-axis after you graph it. So that's how you have to read into this thing. However, let's treat this just like we treated these problems up here. What's our zeros? Well, take the opposite of -7, that's 7, divide by that, it's 2. This is a 2, and so is this. Now I could write this as x minus 2 squared, so maybe this will jump out at you. It's going to bounce off of this x-intercept, or our 0. So 7 over 2 is just 3.5. So just to figure out where stuff goes, so I'm going to put one of my zeros here as 2. 3.5, I'll put it way over here, which is just 7/2. And I got off the picture there. And now I have to think, okay, what is this, a cubic or a quartic? Well, I just pay attention to this and this. If I was to multiply those together, I would get 2x cubed, so I know A is positive, and I know this is a cubic. So what's that telling me? Generally, it's going to look like this. But there is a bounce off here. But I'm going to start with the outer edges, so it's going to go up from that outer edge. It's going to go down from that outer edge. And what do we say about this? It's going to bounce. It's going to go up here, down, and then up. Now the question is, where is it positive? Well, the only place I see is above the x-axis is right here, from here to here. So my answer would be 3.5 all the way up to infinity. And there we have it. A little different, but not much. Okay, so let's go to this one. Now some people would multiply this by a -1 just to eliminate the confusion. And I'm kind of all about that. So x cubed, by the way, you don't have to though. You could factor out a -1, but I like just getting rid of it. So the only twist is, what do you have to remember? You have to remember to flip this. Okay, this is the same math problem as that problem. You just made it look different. Now we're going to factor it. So what can we do? We can take an x out. And then we get x minus 6 greater than or equal to 0. X, this is a trinomial. So that's x. 2 factors of -6 to add up to 1. That'd be +3 and -2. Now my zeros, part A, would be 0 from here, -3 from here, 2 from there. I'm going to put these kind of chronological order, so -3, 0, 2. Now I got to stop and pause. This is a cubic. You see, anyways, I decided to multiply this by a -1. You could have treated this differently and concentrated on where it's below, but because I multiplied by -1, I'm going to concentrate on this statement where a is positive. I know it's a cubic, which means generally speaking it's going to look like this. And this is a 1, that's a 1, that's a 1, so they're not going to bounce off these zeros anywhere. So I start with my outer edge, which represents this, outer edge, which represents this, and I know it goes through here, and I know it goes through here, so generally speaking it looks like that. But wait, you have to read this from this stuff to the inequality, because what does this really mean? Greater than or equal to 0 means 0 or anything positive, which this is telling you, hey, you got to use your brackets. This is saying look for anything above the x-axis. So we got to keep that in mind. That would be from here to here, including the -3 and the 0. So I would write that with brackets, -3 to 0. But then we also have this section. So that would be from 2 all the way up to infinity. Whoops. Parentheses. Can't touch infinity, according to math. All right. Is that it? That's it. All right. Good luck on that assignment, guys.